Here's what nobody mentions about putting AI into your business. The strategy is easy, it's the design that kills projects. You've done the discovery, you know what to build, you know why it matters, and everyone's bought in. And then you start designing and everything falls apart. Because automating customer onboarding sounds simple, but then you realize that you need to integrate Salesforce from 2015, an old ERP system, and then 3 external databases, and then an authentication system that nobody understands. That's the design challenge. In this video, I'm showing you the AI innovation sprint. It's the design method that experts use to design pro AI systems. This is the phase where you shift from should we do this to how we do this. Let's get into it. You're starting the sprint and you have about 20 or so different use cases that you found in discovery. They all pass the 3 Rs, stakeholders are all bought in, and they all scored well for value and feasibility. The purpose of the sprint is to pick the top 2 or 3 use cases that you'll take into detailed design. This is where the risk assessment gets serious. Imagine a healthcare admin company. We'll call them Medicore. They've got 2 use cases in mind. Option A, automate patient intake form processing. Option B, AI-assisted appointment scheduling. On pure value, they're nearly identical. So which one do you choose? This is where risk assessment comes in. You need to think about risk across 4 dimensions. Technical risk is thinking about the complexity of putting this AI system into your business. Operational risk is thinking about the people who will be impacted. Compliance risk is thinking about the regulatory implications. Will you get in trouble legally if something goes wrong? Reputational risk is thinking about if something goes wrong, how are the public going to perceive you? For Medicore's patient intake form processing, I'd say the technical risk is medium. It's really just standard document processing. Nothing really special there. The operational risk is quite low because they can contain this to a back office process. So it's not really going to be impacting or affecting any of their frontline staff or any of their customers. The compliance risk is medium. They still need to adhere to HIPAA compliance, but this is all pretty standard form processing. There isn't really anything to be too concerned about here. The reputational risk is also quite low because a lot of these workflows are happening behind the scenes, and we have a human review step where if there are any errors, they're going to be picked up by the back of house staff. Now let's move on to the appointment scheduling, because I think this is where things get a bit interesting. The technical risk is quite high because it requires a real-time integration with their calendar system, and things can always go wrong when there's real-time integration. If there's a delay in the system, or maybe there's some sort of downtime, it means that some information might be missed. I'd say the operational risk is quite high too, because this is patient-facing. So if the patient somehow gets the wrong information, or if information isn't shared, it can have massive impacts on the patient's experience, and it can also cause delays to the business. And then when we move on to the compliance risk, you can imagine if there's some sort of missed information or wrong information or an error, this is going to cause a massive compliance issue for the business. The appointment errors can impact patient safety. And for that reason, the reputational risk is also very high. So as you can see, these are the same level of value delivered, but the risk profiles are completely different. One is fairly low risk, all happening back of house. Another one is happening on the front end, it's customer facing, means that the risk profile explodes. And it's very clear to see which direction the business should go in if they want to have a successful first pilot for AI. This is why in this situation, I would recommend going with the intake processing. It's a much safer option compared to the automated scheduler. It's lower risk, it's the same value, and it also helps the business build out that capability and enables them to take more risks later on. Now that you've selected the right use case, it's time to understand the process and how AI is going to be injected into it. And when I say process, I don't mean the documented process. It's time to experience the real process. By understanding the real process, you can see all of the different edge cases. Typically when teams document processes, they're documenting the happy path, but if you can see the real process in terms of how it plays out in real life, you can see that there's always a number of edge cases and workarounds that aren't typically documented. Let me show you what I mean with Medicore's intake processing. The documented process says, patient fills out a form, staff enters the data. The data is then validated. The patient record is created. 4 steps, extremely simple flow, straightforward. But the actual process is a bit different. The patient fills out the form that is sometimes incomplete. A staff member gets interrupted by a phone call. The patient returns the form, but the staff member is distracted. When they get off the phone, they read the form and they can't understand the handwriting. The staff member calls the patient to clarify. The patient doesn't answer their phone. The staff member tries again to read the handwriting and makes a best guess based on previous records. They enter the data into the 3 different systems because they don't yet have a sync in between them. They discovered that the insurance information doesn't match between the 3 systems, so they have to manually verify with the insurance portal. They then create a patient record. This is what you're automating, not the fantasy of 4 steps. You want to understand the real process so that you can build those edge cases into your automation. The sprint is about mapping this out systematically. You need to do input analysis to understand what is the data, where is it coming from, and in what format. Then you need to start looking at the different decision points. Where are these decision points and how are they made? How do you know when you're making the right decision? Then next is the transformation mapping, understanding where the information is enriched or changed. And then finally, understanding where the workflow fails so that you can prepare for it and put in safeguards. And then it's also really helpful to understand where the workflow typically breaks. And here's where you start to see critical insights coming out of this mapping process. Across the 18 steps that we identified for Medicore's intake process, there's probably about 4 or so steps here where AI could be really useful. And the rest of them could easily be solved with basic automation. Even something as simple as having a data transfer between systems. No complicated machine learning algorithms, just basic automation, basic AI, and data syncs. And this is what process mapping prevents. Using AI to solve problems that just don't need it. And understanding that there are opportunities out there that could really benefit from using AI. And this is the power of process mapping. It helps you take a bird's eye view of your entire process, identifying bottlenecks, identifying areas where there's friction, and then also identifying the areas where AI can create real value and excluding the areas where AI is definitely not needed. Now we get to the part where most implementations break down, technical architecture. It's really important to think about the 6 barriers that might be holding you back. And there are 6 questions that you can answer that'll help you identify any friction points before you even start designing. The first barrier is connectivity. You need to investigate whether these systems can actually talk to each other. For Medicore, they're trying to connect a practice management system from 2012. They're also trying to connect a modern electronic health record system and a patient portal that's built on a completely different platform. And the practice management system has no API connection at all. There's an open database connection, but this goes against the vendor's terms of service. That's what we call your connectivity barrier. The second barrier is data quality, because even if you can connect, is the data actually usable? When going through this process, Medicore discovered that patient details are stored differently in different systems. For example, in one system, you might see a name spelt John A. Smith, but then in the other system, you'll see Smith John. And then yet another system might say J. Smith. You might find in one system, the insurance ID has dashes, but then in the other system, it doesn't. Also, date formats can vary depending on the system. For you to get any value from implementing AI for this patient intake form, you need to make sure the data is normalized across the systems. That's infrastructure work before the AI work. Now, the next barrier is authentication. How do these different systems handle identity and access? Each system has different authentication. Practice management is only for local database users. The electronic health record requires a single sign-on for users to access. And the patient portal's authentication system is a third-party provider. AI needs to authenticate with all of these different systems simultaneously, which means that you would need to do custom integration work for all 3 systems. Now for the remaining barriers: performance constraints, compliance requirements, and error handling. Each one adds even more complexity. And here is the brutal truth. Integration complexity is almost 5 times higher than AI complexity. You'll spend 5 weeks fighting with system implementation, and then probably about 1 week on AI. This is why the sprint phase exists. It helps teams identify those barriers before they start committing to anything. Now, this brings us to the most important part of the sprint. This is where you decide whether you should build or buy. And this is where most organizations get things completely wrong. They think the question is, should we build a completely custom AI or should we buy something out of the box? But that's not actually the right question. The question should be, what is the minimum viable product that we can release that's going to deliver value? For Medicore's intake process, they evaluated building a custom solution that might be a Python-based document processing, custom Claude API integration, self-hosted on their infrastructure, and it might take an estimated 12 weeks for development. Or another option could be use a no-code platform like make.com or N8N, pre-build document processing, Claude integration via existing connectors, and this might take an estimated 4 weeks for implementation. We can use the following framework to help make our decisions. We also need to think about our internal capability. Do we have the relevant skills and people that we can maintain this over time? What happens if we have 10x the amount of volume? Is this first solution going to be able to scale as we continue to grow? But then also thinking about the total cost of ownership. How much is this going to cost if we continue to scale it? How much is it going to cost over 5 years? I think that for most mid-market organizations, a no-code solution like Make, N8N, or even a solution built with Claude Code is perfect. Not because it's better technology, but more because it's appropriate for the use case. Using some of these no-code platforms, it means that delivering the solution is a lot faster. It also means that you have a lower maintenance burden. Some of these no-code tools, they're so easy to use and understand that you don't need to be a professional developer to modify or update them. You just need to be someone who has decent technical skills. And also because it's a no-code system, it means that it's easier to hand off to operations teams because you can actually visually show them how the workflow works. And it also provides a great platform for them to provide feedback, and you can also update it progressively as they're using it. Unless you're at a massive scale or have unique requirements, custom engineering is typically overkill for these use cases. Alrighty, so let's bring this together. The AI innovation sprint helps you go from what to build to exactly how to build it. You're looking at all of the use cases that you have identified and trying to understand their risk profile. You're mapping out the real process, exactly as it is experienced by the people who execute it. You're not just looking at the happy path, you're looking at all of the edge cases and exceptions. You're looking at the technical architecture holistically, and you're understanding where the barriers might come in. And then you're assessing the build versus buy decision, not based on enthusiasm, but based on the capability. The AI innovation sprint leads to production-ready design decisions. It makes it real. It's not a proof of concept. It's not hoping for the best. And here's the thing, everything we covered, discovery, design, architecture, this is the part that people think about, the strategy and the planning. But what most people don't think about is what happens when the strategy ends, when it's time to actually implement and operate this stuff. That's the next video, and it's where the real operational complexity lives. And if you're finding this valuable, please hit subscribe. I'll see you in the next one. Bye.